Hello everyone. Today we are going to look at optimization problems involving exponential functions. So I have two examples to go through with you. As we do those examples, we will also need to sketch the graph of exponential functions. So we are going to find local max and min, we are going to find points of inflection. Also, we need to find the asymptotes for that exponential functions. So if you have a simple exponential function such as 2 to the power of x minus 5, so you already know how to get the horizontal asymptote for this function. You learned it in grade 11. You also looked at in advanced functions. So we know that horizontal asymptote for this exponential function is y equals -5. Okay, but why is that? What is the real reason that we are getting y equals -5 as a horizontal asymptote here? So the real reason is evaluating limit shows that limit of f of x as x approaches positive infinity or negative infinity or both gives you this value, okay, -5. So let's check it, okay. So if we look at the limit as x approaches positive infinity, 2 to the power of x minus 5. Okay, so using the properties of the limit, actually we can write this as limit of 2 to the power of x as x approaches positive infinity minus limit of 5 as x approaches positive infinity. Okay, so if I take positive infinity and sub for x, so you get 2 to the power of very big number here. Okay, so 2 to the power of very big positive number will give you a very big number. So if we try it with our calculator here, let's say substitute 100 for x. It is not even a big number, but exponential functions grow so quickly that if you substitute a very big number here, the calculator cannot even calculate it. So if we have 2 to the power of 100, you get 1.26 times 10 to the power of 30. So that's a very big number. Again, if you try to substitute even a bigger number, so your calculator won't be able to even calculate it. It is so big. So therefore, we can say that as x approaches positive infinity, limit of 2 of x approaches positive infinity. Okay. Now we are going to subtract limit of 5 as x approaches positive infinity. So if we have a constant here, right, it doesn't matter where x approaches to. So you will get the same constant as a limit. So we have 5 here. So when you subtract a number from infinity, it is because infinity is such a big number, it is not affecting the value of it. So we end up with positive infinity here. Okay, so let's look at the limit of 2 to the power of x minus 5 as x approaches negative infinity. Again, if we use the properties, so we can separate these two terms and we can say limit of 2 of x as x approaches negative infinity minus limit of 5 as x approaches negative infinity. Now we are going to substitute negative infinity for the exponent. Okay, so if we do 2 to the power of, let's say, -100. Okay, so to get rid of that negative exponent, so you would move it to denominator and you would get 1 over 2 to the power of 100. So basically you are dividing 1 by a very big positive number. Okay, so then this will give you a very small number, 0.0. Let's say, let's use our calculator, 1 over 2 to the power of 100. So this will give you 7.8 times 10 to the power of -31. So this is a very small number. Okay, so then we can say that this value approaches to 0. Okay, so it is very small that it is almost 0. And again, limit of 5 as x approaches negative infinity is still 5. So 0 minus 5 gives you -5. So as you see, as x approaches positive infinity, the function approaches the positive infinity. However, when x approaches negative infinity, function approaches to -5. So this is where we are getting the horizontal asymptote. So y equals -5. So if you were to sketch this function, so you know that you will have now a horizontal asymptote at y equals -5, okay? So as x approaches positive infinity, y approaches positive infinity, so that is one end behavior. And as x approaches negative infinity, y approaches -5, and this is the other end behavior. So you can see that, you know, the function is approaching to -5 on the left side, on the left end. All right. So let's look at some examples for the limits. If we have a base greater than 1, okay, so let's say 2 to the power of x, as x approaches -infinity, so you get 0. We just discussed that, right? So we said that if you have, again, let's say 2 to the power of a very big number, so we said that that is approaching to 0. So that is what it is. So limit of a to the power of x as x approaches positive infinity is positive infinity. Again, we check the limit of 2 to the power of x here, okay, as x approaches positive infinity, and we said that we are getting a very big number, so that is positive infinity, okay? So those are for the exponential growths. How about if you have a base that is between 0 and 1, okay? So those are exponential decays. So in this case, limit of a to the power of x as x approaches negative infinity equals positive infinity. So let's try this. So let's say we have limit of 1 over 3 to the power of x as x approaches negative infinity. So you're substituting a big negative number for x. So to get rid of that negative exponent, so you need to flip the fraction here. You get 3 over 1 to the power of positive 100. And again, this is a very big positive number. So the limit is positive infinity. And that's where it is coming from. Let's look at the second one. Limit of a to the power of x as x approaches positive infinity equals 0. So let's try it again, because a is between 0 and 1. So this time we are looking as x approaches positive infinity. So you are substituting a big positive number here. So this gives you 1 to the power of 100. So 1 to the power of anything will give you 1 over 3 to the power of 100. So you are dividing 1 with a very big positive number. So you are going to get again a very, very small number that is close to 0. So limit is 0 here. Okay. So we could also apply this to e to the power of x. Again, let's remember e is 2.72 approximately. So you are so the value is, the base is greater than 1. So it's gonna act like this here. Okay. So limit of e to the power of x as x approaches positive infinity will give you positive infinity. Limit of e to the power of negative x as x approaches positive infinity, 0. So let's look at it for a second. So you are having a limit of e to the power of negative x as x approaches positive infinity. So you are getting e to the power of negative infinity. Okay, so let's substitute a value here, or we can even write the decimal value. Okay, so 2.72 to the power of negative 100, let's say. Okay, so to get rid of this negative exponent, so you can write this as 1 over 2.72 to the power of 100. Again, you are dividing 1 by a very big positive number, so that number is a very small number close to 0. So that is the reason limit of e to the power of negative x as x approaches positive infinity equals 0. So let's do some examples here. Okay, so this is the given examples. again, limit of 3 to the power of x as x approaches positive infinity, positive infinity. So when you substitute a very big positive value for the exponent, so you get a very big positive number. So let's check the second one. Limit of 1 over 2 to the power of x as x approaches positive infinity is 0. Again, so this gives you 1 to the power of very big number, which is 1, divided by 2 to the power of very big number. So 1 over a big number gives you almost 0. So that is the limit. Let's check this one. Limit of e to the power of x as x approaches negative infinity. So e to the power of very big number, negative big number. So again, to get rid of this negative exponent, you can write this as 1 over e to the power of 100. You are dividing 1 with a very big positive number. So you're getting almost 0. Okay, so that is the limit. And this one, 1 over 3 to the power of x. So we are looking at the limit as x approaches negative infinity. So 1 over 3 to the power of negative big number. So that gives you, again, flip it, you get 3 over 1 to the power of 100. This is a very big positive number, therefore the limit is positive infinity. So let's look at close examples. So limit of 5 to the power of x as x approaches positive infinity. So 5 to the power of very big number. So this will give you, okay, a very big positive number. So positive infinity. Limit of 1 over 6 to the power of x as x approaches positive infinity. So this gives you 1 to the power of big number, which is 1. 6 to the power of very big positive number. So you're dividing 1 by a very big positive value. So this gives you 0. Limit of e to the power of x as x approaches negative infinity. Actually, we just did it with the previous example. So that is 0. So let's move on and look at the next one. So limit of 1 over 10 to the power of x as x approaches negative infinity. So 1 to the power of, let's say, so 1 over 10 to the power of negative 100. Okay, so to get rid of that negative exponent, you flip the fraction inside for the base, so you get 10 to the power of positive 100. Okay, so this again is a very big number, and you get positive infinity. So let's look at this limit. So limit of negative x squared times 6 to the power of negative x. So we are again, we are looking at the limit as x approaches negative infinity. So you're kind of substituting a very big number here. So negative infinity squared, 6 to the power of negative infinity. Okay, so when you are squaring a negative number, you know that if the exponent is an even number, so you get a positive number. If the exponent is an odd number, then you end up with a negative number. When you're squaring negative infinity, okay, so you get a positive big value. So this will give you then negative positive infinity, and now you have 6 to the power of negative times negative gives you positive, so 6 to the power of positive infinity. So 6 to the power of very big number. So that will give you again a positive infinity. So positive infinity is another positive infinity, and you're multiplying it by a negative value. So you end up with negative infinity here. Okay. So let's look at f. Limit of 8 over 6 plus 5 times e to the power of negative x as x approaches positive infinity. So 8 over 6 plus 5 to the power of, okay, so big 5 times e to the power of very big negative number. Okay, so let's say e to the power of negative 100, and we already know that we will get 0 for this. Okay, so you basically get 8 over 6 plus 5 times 0, which is 0. So you end up with 8 over 6 here. So if you reduce the numbers, you get 4 over 3 as a result. Next one, limit of negative x to the power of 5 times e to the power of x squared as x approaches negative infinity. So in this case, again, if you substitute infinity, so you are squaring negative infinity, you get positive infinity. So again, if you have a negative base with an odd exponent, you know that you're going to end up with a negative value. So negative infinity, so e to the power of positive infinity is positive infinity. So negative gives you positive, infinity times infinity is still infinity. So you end up with positive infinity here. Okay. So let's look at example 2. Find the horizontal asymptote of y equals negative x cubed times e to the power of x minus 6. So to get the horizontal asymptote, again, we need to check the limit as x approaches negative infinity and positive infinity. So positive infinity, negative x cubed e to the power of x minus 6. So let's do it here. So negative, you are cubing the infinity, and e to the power of infinity minus 6. Okay, so this gives you here negative, so infinity cube is still infinity. E to the power of infinity again is a very big number, so let's say infinity, and you get minus 6. So infinity times infinity is still infinity, times negative sign, that will give you negative infinity. And when you're subtracting 6 from a very big number, you still get that big number. So you end up with negative infinity. So let's check the limit as x approaches negative infinity. Okay, so this time you're subbing negative infinity. Okay, so negative infinity cube, still negative infinity. Okay, e to the power of negative infinity, e to the power of, let's say, negative 100, and we see that that is approaching to 0. So you're getting infinity times 0, which is 0. So this will give you 0 minus 6. So the result is negative 6. So then the horizontal asymptote is y equals negative 6. So when we are dealing with exponential functions, more complex exponential functions, sometimes the function is going to approach to that horizontal asymptote only at one end, and sometimes both ends of the graph will approach to that horizontal asymptote. In this case, we see that because see when the limit as x approaches positive infinity is negative infinity, so it's not approaching to the horizontal asymptote. But when we look at the left end of the graph as x approaches negative infinity, okay, so we get negative 6. So this function approaches to this horizontal asymptote on the left side, on the left end of the graph. Now you can practice these limit questions here, and then we are going to look at optimization problems involving exponential functions.